Welcome back, students, again. Now we will discuss one more important question from the determinant. Question 18 from our sheet. Using the properties of determinant. It is the use of factorial. Factorial n plus 1, factorial n plus 2. We have to find its value. Factorial n plus 1, factorial n plus 2, factorial n plus 3, factorial n plus 2, factorial n plus 3, and finally factorial n plus 1. Remember, if we write factorial 4, it means that it is 4 into 3 into 2 into 1. If we write factorial 5, it is 5 into 4 into 3 into 2 into 1. It means 5 into, if you take it from 4 to 1, it is factorial 4. Similarly, we can write factorial n into factorial n equals to n into factorial n minus 1. If there is factorial n plus 1, we can write n plus 1 into factorial n. If there is n factorial n plus 2, we can write n plus 2 into factorial n plus 1. If there is factorial n plus 3, we can write n plus 3 into factorial n plus 2. If there is factorial n plus 4, we can write n plus 4 into factorial n plus 3. So these values will be used first of all in the first row. Factorial n is already there, which is the smallest of the three. Factorial n plus 1, and factorial n plus 2. So first we will expand factorial n plus 1 as n plus 1 into factorial n, and factorial n plus 2 as n plus 2 into factorial n plus 1, and then factorial n plus 1 is again written as n plus 1 into factorial n. So factorial n is common in all the elements of first row. Similarly, n plus 1, factorial n plus 1 is the smallest factorial in second row. So first we write factorial n plus 1, then second row, second element will be expanded as n plus 2 into factorial n plus 1, then factorial n plus 3 is expanded as n plus 3 into n plus 2 into factorial n plus 1. Then factorial n plus 2 is the smallest element of third row. N plus 3 is expanded as n plus 3 into factorial n plus 2, n plus 4 is expanded as n plus 4 into n plus 3 into factorial n plus 2. So we observe that in first row n is common. Factorial n is common in first row. In second row, factorial n plus 1 is common. In third row, factorial n plus 2 is common. So we write 1, n plus 1, n plus 2 into n plus 1 as the first row of this determinant. These all things are the rough one. Second row, factorial n plus 1 common. So 1, n plus 2, n plus 3 into n plus 2. And in third row, factorial n plus 2 common. So 1, n plus 3, and n plus 4 into n plus 3 will be there. Now there are 3 ones in the same column. So we can easily bring the zeros if we operate R1 as R1 minus R2, or observe it, R3 has the larger element. So if we operate R3 as R3 minus R2, so first element of R3 minus first element of R2 is 0. N plus 3 minus n plus 2, n cancel out, 3 minus 2, 1. And when we subtract n plus 4 into n plus 3 minus n plus 3 into n plus 2, n plus 3 is common between them into n plus 4 minus n minus 2, so it is 2 only. Again, if R2 is operated as R2 minus R1, it is again giving 1 minus 1, 0. N plus 2 minus n minus 1 is 1 again. And n plus 2 into n plus 1 and n plus 3 into n plus 2. So n plus 2 will be common into n plus 3 minus n minus 1. So it will be 2 only. So 1, n plus 1 and n plus 2 into n plus 1. So we can bring one more 0 if we again operate R3 as R3 minus R2 as there are 1 and 1 in both the rows as the second element. So if we again operate R3 as R3 minus R2, first write all the terms outside the bracket, then operate R3 as R3 minus R2. So 0 minus 0, 0, 1 minus 1, 0, and 2n plus 6 minus 2n plus 4, 2n, 2n cancelled out, 6 minus 4, 2. All the elements are, remaining elements are written as they are. First row is also written 1, n plus 1, n plus 2 into n plus 1. So there are zeros below the principal diagonal. So if we multiply, it is 1 into 1 into 2, that is 2. So 2 into factorial n into factorial n plus 1 into factorial n plus 2 will be there, which is the value of this determinant. I think you must have understood it. So practice it with the method which I have discussed and ask your doubts in comment box if you have any again and again till you don't get the solution. Welcome back students again. Now we will discuss one more question related to properties of determinant, a very important question. The question number 9 from our sheet. If x is not equal to y, y is not equal to z, and x square 1 plus x cube, y square 1 plus y cube, z square 1 plus z cube equals to 0, then prove that x, y, z equals to minus 1. Clearly, it will use the switching property as the third column has two elements each, 1 plus x cube, 1 plus y cube, 1 plus z cube. So if we switch it along the third column, it becomes x square 1, y square 1, z square 1, plus second determinant becomes x square x cube, x square x cube, second determinant, second row, y square y cube, and third is z square z cube, and it is already given that it is equal to 0. So we write switching about C3. Now, if you observe, we can cross the third column 1, 1, 1 by 2 columns. So it moves to the first, and first column is shifted to the second column. Second column is shifted to the third column. So the elements are in increasing order and there will be no effect in its value, as whenever a column crosses 2 columns, we have to multiply by minus 1 whole square. Plus, in second determinant, we observe that x is common in first row, so take it common. Y is common in second row, so take it also common. And z is common in third row, so take it also common. So 1 x square, 1 y square, 1 z square equals to 0. Clearly, this determinant is common between the two. It implies 1, 1, 1, x, y, z, x square, y square, z square determinant is taken common. So it gives 1 plus x, y, z equals to 0. Now, first, if we expand the first determinant, we have already discussed this expansion in question number K above. Look at this, it is same. No, it has x cube. So one more is there when there is x square. And this expansion was actually it is indirectly obtained from this E, or this is D. D also is same, only two rows are altered. That's why it has minus outside it. Otherwise, it is A minus B, B minus C, C minus A. Similarly, when we expand this, we'll get, or you can also expand it to give. Though our answer has been obtained from the second column, but we have to prove that the first determinant is non-zero. Either this determinant 1, 1, 1, x, y, z, x square, y square, z square equals to 0, or 1 plus x, y, z equals to 0. It implies on solving the first determinant to bring zeros, we can write, we can use as R1 is operated as R1 minus R2. So 1 minus 1, 0. X minus y, x square minus y square on factorization gives x minus y into x plus y. R2 operated as R2 minus R3. So again 1 minus 1, 0. Y minus z, and y square minus z square is y minus z into y plus z, then 1 z, z square equals to 0. It implies from the first row x minus y is common, from the second row y minus z is common. So 0, 1, x plus y, 0, 1, y plus z, 1, z, z square equals to 0. And in the question it is given that x is not equal to y, means first one x minus y equals to 0 is inadmissible. The first factor is inadmissible. Why? As it is given that x is not equal to y, so x minus y is non-zero. Second factor y minus z equals to 0 is also inadmissible. We have to write or. And third factor is this determinant itself. And if we again want to bring 0, so we again use R1 operated as R1 minus R2. So 0 minus 0 will be 0. 1 minus 1 will be 0. X plus y minus y plus z will be x minus z. Second row is written as it is 0, 1. Y plus z. Third row is also written as it is 1z, z square equals to 0. It implies on changing first and third column, we are getting minus x minus z, y plus z, z square, 0, 1, z, 0, 0, 1. So all the elements above the principal diagonal is 0. So its value will be obtained by the product of elements of principal diagonal x minus z only, which is also inadmissible, as in the question it is given that x is not equal to z. Why x is not equal to y is not equal to z. All three are different. Means only second factor remains now, which is 1 plus xy z equals to 0, where we have written. So we then write or x, y, z equals to minus 1. Hence proved. But don't leave it without solving in subjective exams. Go in objective exams, you can directly write x, y, z equals to minus 1. But in your board exams, where there is subjective exams, you have to solve it completely by clearly showing that x is not equal to y is not equal to z, x is not equal to z. So x minus y is non-zero, y minus z is non-zero, and z minus x is also non-zero. So we cannot take them as the factors. Okay. So hope you all must have understood. So solve it to get the real answer. Okay.